All right, today what we're going to do is we're going to expand on our previous lesson of our composition of functions using our quadratics, radicals, and rational functions. Now let's remember back to what these functions are. Quadratics are ax squared plus bx plus c. Our radical functions are our square roots, and our rational functions are our fractions. So let's go through some examples. Looking at adding two rational functions. So we're adding the functions. We need to take f of x first, which is 2x over x plus 1. Tells us we need to add that to our g of x function, which g of x is 4x plus 5 over x plus 1. Now here we need to pay attention because we're adding, our denominators must be the same. Okay, so we need to look at that. X plus 1 and x plus 1, yes, they are the same. So this is going to make our problem very nice and easy because all we have to do is write down that x plus 1 one time, take our operation, which it says plus, and take 2x for our f of x function and 4x plus 5 for the g of x function. And now in the numerator, all we have to do is simplify our numerator. So combine like terms, 2x and a positive 4x will give us 6x, and then the plus 5 with the constant all over x plus 1. Now remember from the previous lesson, I was really big on making sure that we group everything and we keep things in parentheses. Our top parentheses of 6x plus 5 does not match our parentheses of x plus 1, so nothing will cancel. Nothing will simplify from there, so that is our final answer. Let's look at another example. What happens if we look here, look at the g of x function and f of x function. We have 5x as the denominator here, and we have 2x here. They are not the same denominator. So we're going to have to get common denominators here. So let's go ahead and start with our writing it out. So we write out our f of x function, 2x over x plus 5. And we take our g of x function, 3x all over x plus 2. Now we have to have common denominators. Again, remember I like my parentheses. So we have to take our x plus 5 to the g of x function on the top and on the bottom. And we have to take the x plus 2 denominator of the g of x function to the numerator and denominator of the f of x function. So when we write all of this out, I have common denominators. So I'm just going to go ahead and write that down only one time and get x plus 2, x plus 5. Our sign in the middle is a plus sign. So I take everything on this side. For our f of x function, I have 2x times x plus 2. I take everything over here, and I have 3x times x plus 5. Now what I need to do is distribute out the top and combine my like terms. So first, I'm going to distribute. So I'm going to have 2x squared plus 4x. I got that by distributing the 2x plus, because I have the plus sign here, and now I need to distribute out that 3x. So I'm going to get 3x squared plus 15x. Now, what I need to do is I still have that all over my denominator of x plus 2 and x plus 5. So now what I want to do is make sure that I combine my like terms. I have x squares of 2x squared and a positive 3x squared, which will give me 5x squared. And I have a 4x and a 15x, which will give me 19x all over x plus 2, x plus 5. And that will be my final answer. Now let's go on. Let's see what other types of problems we can work out and what other examples we have. Square roots. What are we going to do? Oh, we got this little magician over here. What are those numbers he has? 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are our perfect squares. Because if we take the square root of 4, we get 2. We take the square root of 9, we get 3. We take the square root of 16, we get 4. The square root of 25, we get 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. Now we could keep going through a lot more of those, but those are what I call the magical numbers when we look at our radicals. We look at our square roots. Because what we want to do is before we can add the square root of 75 plus the square root of 12 together for our f of x and g of x functions, we need to break these down. The square root of 75, what number over here in our magical number bank can 75 be divided by? I almost said it. That's 25 times 3. 25 times 3 is 75. So the square root of 25 times the square root of 3 will give us the square root of 75. Well, just like we did before, the square root of 25 is 5. So the square root of 75 can be written as 5 square roots of 3. Plus, well, let's look at that square root of 12. Well, square root of 12, 12 can be divided by 4 and 3, because 4 times 3 gives us 12. We need to put square roots because it's underneath the square root. Just like when we did the square root of 75, the square root of 4 is going to be 2, so that breaks down, and we get 2 square roots of 3. Now, the unique thing about this one is our square roots work just like our x's and y's. If we have the exact same square root number, we can take those coefficients out front and we can add them together because that's the sign that's in between them. So now I can take 5 plus 2, which gives us 7, and we have 7 square roots of 3. So, looking through our problems, let's go on to another radical, or actually we're going to go on to another rational problem. So what happens if we go to a rational problem where we have multiplication? We talked about this in the previous lesson. Let's go ahead and revisit again. So if we have 4x over x plus 1 times 8 over 3x. Remember, I'm big on the parentheses. So let's multiply straight across, and we're going to get 32x all over 3x times x plus 1. I like that parentheses because that 3x has got to be multiplied to the x and the 1. So we'll have 32x all over 3x squared plus 3x. Now, there's something that I could have canceled out the step before that I'm noticing now. Each one of my terms has an x in it. So I can get rid of an x out of every single term. Now here I have x and x, so I can only get rid of one of them, so I'm still left over with an x. So fully simplifying this, I'm going to have 32 all over 3x plus 3. And that'll simplify it down a lot better. All right, let's move on to the next example where we're going to multiply our square roots here. Multiply our radical functions. Now let's take our f of x, which is the square root of 75, times the square root of 12. Now there's two ways we can do this. So let's go ahead and write out our way number 1 first, and then we'll go with way number 2. So There's two options here. Now, a lot of us see it, okay, well, it's multiplication, so the first thing I need to do is take the square root of 75 times 12. And when I multiply that together, I'm going to get the square root of 900. And then you got to think, how is that going to break down? Or punch it in your calculator and see what the square root of 900 gives you. Well, if you punch the square root of 900 into your calculator and take the square root of 900 and hit enter, it automatically works out to be 30. But if you don't have a calculator, well, how would you do that? Well, we're going to take this 30 and drift it over to the side real quick and look at it. Now, if we take our numbers 2, 4, 9, 16, 25, 36, 49, 64, 81, and 100, I always start with the largest number and try to divide it. So 900 does divide by 100 by 9 times 100. So the square root of 9 times the square root of 100 would give us the square root of 900. The square root of 9 is 3. The square root of 100 is 10. So that would give us 30. So if you didn't have a calculator, that's the way to break down the square root of 900 by hand. Well, some of us may be so used to breaking down our radicals, our square roots, that's the very first thing that we do. We look at the square root of 75 and say, okay, that's the square root of 25 times the square root of 3. And we say, okay, that's 5 square roots of 3. And then we look at the square root of 12 and say, okay, that's 4 times the square root of 4 square roots of 3 times the square root of 3, and we'll get 2 square roots of 3, and then we need to multiply that together. Now remember, multiplication can be done in any order. So that can be 5 times 2 times the square root of 3 times the square root of 3. 5 times 2 gives us 10. So 5 times 2 gives us 10. The square root of 3 times the square root of 3 is 3, so that would give us 30. Now the square root of 3 times the square root of 3 is the square root of 9, which is 3. Or you may have been taught that the square root of 3 times the square root of 3 is the square root of 3 squared, and that a square and a square root cancel each other out, so you just are left with 3. Let's go on to look at our next example. Our next example says, what if we have the same square roots, but now we are dividing? So that's going to be the square root of 75 divided by the square root of 12. Well, that's the square root of 75 divided by the square root of 12. Well, let's break it down. Since we've broken down the square root of 75 so many times, we should know that that's 5 square roots of 3. The square root of 12 is 2 square roots of 3. And very nicely, our square roots of 3 will simplify down and go away. So all we're left with is 5 halves. So that worked out very nicely. What happens, though, when we don't have such nice square roots? That'll just simplify out, and our radicals or our square roots cancel each other out. Well, let's look at that. That would be the square root of 50 divided by the square root of 12, which is the square root of 50 over the square root of 12. And when we look at this, the square root of 50, let's do a little scratch work, breaks down as 25, the square root of 25 times the square root of 2, which is 5 square roots of 2. We've worked out several times the square root of 12, so we should know that that's 2 square roots of 3. Now look here, our square root of 12, our square root of 2, and the square root of 3 are not the same. So they're not going to go away, and they're not going to simplify down. Well, we can't leave a square root in the denominator, so we need to multiply the denominator and the numerator by the square root of 3 so that we can get rid of our square root in the denominator. When we do that, we're going to have 5 times the square root of 2 times the square root of 3 in the numerator, and 2 times the square root of 3 times the square root of 3 in the denominator. We just worked out a second ago that the square root of 3 times the square root of 3 equals 3. The square root of 2 times the square root of 3 is going to give us the square root of 6. So this is going to work out and give us an answer of 5 square roots of 6 all over 2 times 3, which is 6. Great job on our problems today.